All right, let's dive into a question that hits pretty close to home, right in your wallet, actually. Can your smart dishwasher and your power company finally get on the same page? And can they do it in a way that helps everybody?
I mean, have you ever really thought about this? You get home from work, you kick off your shoes, start making dinner, maybe toss a load of laundry in, and bam, all of a sudden, you're paying top dollar for every bit of power you use. What is so special about 6 p.m.? Well, it's pretty simple, really. It's because pretty much everyone is doing the exact same thing you are at the exact same time. This creates a massive, massive spike in demand. It's basically the energy grid's version of a traffic jam. The whole system gets strained, and just like those rush hour tolls on a highway, the price shoots way, way up. And this whole situation has a name. Engineers call it the 6 p.m. problem, or, more broadly, the challenge of peak load. And figuring this out, well, that's one of the biggest puzzles we have to solve to create a smarter, more efficient energy grid for the future. The main game plan for tackling this is something called demand-side management, or DSM. The idea behind it is actually super straightforward. Get people to run their power-hungry appliances, think washing machines, EV chargers, during the cheaper, off-peak hours instead of right in the middle of that 6 p.m. chaos. But here's where it gets tricky. This whole strategy sets up a classic tug-of-war. You've got two major players in this game, and let's just say they want very different things. It's what you, the consumer, want versus what the utility provider needs. So, on one side of the rope, you've got us, the consumers. Our goal? Super simple. We want to pay as little as possible for electricity. But on the other side, you've got the utility provider. Their number one priority is keeping the grid stable. They absolutely hate those giant sudden spikes in demand because, they can lead to serious instability, maybe even blackouts. So let's play this out. What if we just focus on what the consumer wants? Well, a computer model could easily spit out a schedule that gets you the absolute rock-bottom price on your bill. But the trade-off? A crazy high peak load that pushes the grid to its breaking point as everyone's appliances kick on the very second the price drops. Okay, now let's flip it. What if the utility always gets its way? They get exactly what they want. A nice, flat, predictable demand curve with zero scary peaks. The grid is perfectly happy and stable. But for you and me, the cost of energy is higher than it needs to be. It's safe for sure, but it's not cheap. So for the longest time, it seemed like you had to pick one or the other. But what if you didn't have to? What if there was a way to find a real compromise? Well, researchers from Multimedia University in Malaysia have come up with a really clever new model that acts like a compromise dial to find a solution that actually works for everyone. And that's exactly what the researchers were aiming for. They say it right in their paper. Their whole goal is to find this perfect balance. This isn't about one side winning. It's about crafting a schedule that keeps your bill low and keeps the grid safe and stable. So how'd they pull it off? It's a really brilliant two-stage process. First, their model figures out those two extremes we just talked about, the absolute cheapest schedule for you and the absolute flattest, safest schedule for the utility. Then, it uses those two bookends to find the best possible compromise right there in the middle. And this is the secret sauce. They created a variable called a balancing weight. The easiest way to think about it is like a dial. If you turn it all the way to 0, the model is 100% focused on the utility's goal of a low peak. If you crank it all the way to 1, it's 100% focused on your goal of a low cost. And everywhere in between, well, that's where the magic happens. Okay, this all sounds fantastic in theory, right? But does it actually work in the real world? Well, the researchers ran a simulation to find out. They modeled a pretty typical house with all the usual appliances. You see the dishwasher, the washing machine, but look at the last one. They included an EV charger, which is a huge power draw, and one of the biggest new challenges for the grid today. Okay, now this chart is where it all comes together. The blue bars show your energy costs, and that orange line is the peak load on the grid. Now watch what happens as the researchers turn that compromise dial, they call it alpha here, from 0 up towards 1. Your cost drops, which is great, but look at the orange line. The peak load stays nice and low and stable until it hits about 0.6, and that's when it starts to jump up. So what does this prove? It proves that a sweet spot is real. It actually exists. There is a perfect range where you can get a serious discount on your bill without creating a dangerous spike in demand for the power company. You don't have to pick an extreme. And this is so cool. This shows you what one of those balanced schedules actually looks like. Each row is a different appliance, and the little asterisks show when it's scheduled to run. You can see how the model is smart enough to shift the really big power hogs, like the EV charger, that's number 7 there, to the wee hours of the morning when nobody else is using power. It keeps the grid stable and it keeps your costs down.
So why is this such a big deal? I mean, this isn't just about saving a few bucks here and there. This kind of intelligent balancing act is absolutely fundamental to building the energy grid of the future.
Think about it. A smarter grid means we can actually charge all the electric cars that are coming online without crashing the system. It means we can more easily integrate renewables like solar and wind, which, don't always produce power when we need it most. And yeah, it leads to lower bills for us and just a more reliable power supply for everybody.
So the real takeaway here is that we can finally move past this old conflict. We don't have to choose between cheap and stable. This research shows that with some smart thinking, we can build a system that's cheaper for us, safer for the utility, and, frankly, better for the planet. It is a genuine win-win.
And that leaves us with a pretty fascinating thought for the future, right? Just imagine a day when your house just does this for you. It automatically negotiates the perfect energy schedule every single day, finding that perfect sweet spot for you, for your neighbors, and for the entire grid. Thanks for tuning in.